Right, so in these ones, we want to find what value of a makes the function continuous. So this is a question about limits, technically, right? So we know that to be continuous, the limit as x approaches some number, so in this case 2, from the left direction, has to be equal to the limit as x approaches 2 from the positive direction. Technically, would also have to equal f of, in this case, 2. But since this is defined whenever x is greater than or equal to, right, this value here is going to be equal to f of 2. So what this means is that as we approach from the left, we're taking the limit as x approaches 2 from the negative direction of x squared minus 3x plus 7. This should equal the limit as x approaches 2 from the positive direction, right? That's going to be an ax plus 9. So both of these are just well-defined polynomials that would obey the substitution rule. So I can just plug in 2. So 2 squared is 4 minus 6 plus 7. That should equal, I can plug in the 2 there, 2a plus 9. So what are we getting? We're getting 11 minus 2, so we're getting, what did I say? 11? 11 minus 6. That should be 5 equals 2a plus 9. Let's get 5. So 2a is -4, so a should be -2. Now, for these questions, you can always just check that you have the right answer because you can just throw things into Desmos. So again, I recommend you do those things. So we have x squared minus 3x plus 7, but that's our first function. If we want to make sure that we're only graphing whenever x is less than or equal to 2, we can do a greater than x less than 2. So then we can just get that part of the domain. And then we had ax plus 9. Let's add in a slider. And let's also restrict this domain to only being values of x that are greater than 2. So x is greater than or equal to 2. Right, so then this value of a, right, sliding it around is going to make this either continuous or not continuous. We found that the only value was -2, which we can see makes our function kind of connected there.